Copying it, my drive. Let's create a new folder for lab 6 tables. Then once you have that done, you'll notice that in there, there's a couple different things that might be sort of important. There's the soils of Notre Dame. That's just a completed shapefile of all of those. And we have the 3 tables where actually, that's just so you can follow along with something if you didn't finish your soil map. And then the other 2 things that we're going to be working with are the soil descriptions, other 3 things, soil descriptions, and then the water measurements and water sites down here. I think I said in lecture that I was going to give you something as a CSV and something as a PDF. For some reason, I just gave them all as DBFs. Doesn't make a difference, it's just harder to open if you wanted to look at them. All right, so go ahead and fire up ArcGIS Pro. We're going to start our new project file as usual. This is one that you probably would be fine to just load the one from last week and bring things in. There's not really anything different you're doing. And if for some reason you didn't save your soils as a shape file, you will need to go find them. But I'm going to create a new project just so I have it. I'm going to call it Lab 6. And I'm just going to send it off to my drive. Just uncheck the creative folder, just makes it all in the same one. We're going to start off with just adding in the soils and the soil descriptions. So we're going to start off with just creating a one-to-one relationship between a couple of different things. So let's go ahead and go, if you don't have a catalog tab up, again, you can get to it through view, catalog pane, pop it up over here. And we're in folders, Lab 6. I'm going to bring in soils, Notre Dame, and soil description, St. Joseph. This again is not super accurate. I had to futz with these to make the soils that are actually in the counties north of us in Michigan line up with ours. So don't use those for real science. I can point you in the direction of the right ones if you need them. You can also go into Lab 5 and find the soils that you did last week if you've already finished them and you just want to start that process now. So I'm just going to bring those 2 things over. And what you'll notice is I have this completed soil map in here. And then I have a standalone table listed down at the bottom here that's called soil descriptions. If I right click on this and go to open, it'll bring it up. And what you have is for each one of the units that are in there, which one of the soil types, it has a single record that is the name and then sort of just a classification of whether it's prime farmland or not. So useful things if you live in farm country where you want to know this sort of stuff. And then all the different classes have been sorted in there. The MU sim, MU name, that just means map unit symbol and map unit name. Just instead of soil code, that's just what the database called them. So, same thing, just it's a little bit different. And then if you open the attribute table for the soils, that's where I've gone through and I've done what you did and just created all of the ones in there with soil codes in place. And what we want to do is that one-to-one relationship between them. In this case, there are multiple soil codes, like multiple instances of each soil code. So the one over there is just saying for every unique soil code, it's going to look up one unique like map unit description in the soil descriptions one. So that's the kind of one-to-one that's happening there. So to set this up, you've got a couple places you can go to do it. With a join, you start with the thing you want to add stuff onto. So you can either right click over here in soils and go to joins and relates, add join. It's also in somewhere hidden in the attribute table. Usually it's over here now. Joins and relates, add join. But regardless, just right click, joins and relates, add join. And it's going to look like the images that I showed in class, where we have this idea where we have an input table, we have the field that's in one of them, the table we're going to join onto it, and then the join field also. So soils Notre Dame. If you have multiple things in, it's not going to necessarily default to the right one. This just happened to be because there's only 2 things in, so it just found the other thing. We called ours soil code. In the other one, it's MUSIM. It's not that smart. It's only just looking at the first field in there that's text. It didn't like guess intelligently. If they'd been in a different order, it would have been wrong. And then you'll see you have this little like warning over here. That's probably just saying that this one isn't indexed. It's not a big deal. Just if you have a really massive database, indexing it will make it do it a little bit faster. Yes, got it right. All right, so when we go ahead and do this and we hit OK, it's going to automatically, and in fact, if you saw down there, it already pulled them into the table because I had the table open. It's that fast to do it. And it'll find those cases where we have the soil code and a matching soil code in the standalone table, that soil descriptions one over there. So if it wasn't already obvious, soil code W is water. It probably was less obvious that soil code UMWB was urban land Tracy complex, and then probably a slope way off on the end there. Yep, 1 to 5% slopes. So it should have found most of them. Well, you notice in there that there's occasional places where it has a null. Fixing those is kind of your next step here. This might be a case where it's actually nice to take your just grab the attribute table here and just pull it out so you can make it a little bit bigger. Because there's going to be a few cases, almost certainly, where you entered in a code and it couldn't find it in the database. All of the codes should be in the database. It's almost certainly because you put a space at the beginning of it, or you put 2 capital letters instead of 1, or you put a lowercase l instead of an uppercase I, or vice versa. So you're probably going to need to find and correct those things. The best way to do that is twofold. One, first to find them all. The easiest way to do that is just find one of the things that's from the join table. Probably MUSIM is the best here. Right click on it and go sort ascending. That's going to start with all of the null values. Unlike some programs that just ignore null values and won't sort on them, ArcGIS will put the nulls at the top if you're ascending. So we can see those now and we can kind of see what's happened. The next easiest thing to do to make this a little bit better is if you don't already have, if you didn't just load up your Lab 5 folder or your Lab 5 project, you probably want to add in the soil map again so you can see again what the mistake was. So if you haven't done this recently, you're just going to go to folders, add folder connection. I just right clicked on the word folders over there, went to add folder connection. And instead of going all the way into lab 6 here, I'm just going to go back to like my base GIS folder and just choose that. So now I've just made a connection in there to GIS folder. You could also go in through add data if you're on your map viewer over there. I'll leave that because I'm going to use it. And I'm just going to go into Lab 5 creating vectors and just drag over soils Notre Dame, just so I have it in there as well. Only going to use it for this error checking piece, just to be able to find out if I made any mistakes. I obviously did. Or find out what the mistakes are, I guess. So if you remember, I've told a few of y'all this when we're editing and things. If you want to go to a particular polygon, if you want to just jump to it, if you have the attribute table up, I'm going to redock this just because it's really hard to see on my like zoomed in monitor. And I've only got 4, you can see them here. If I want to go to one of these polygons, I can just click on the row number over here. And if I double click on that, it'll jump me right there. I can turn off the soils.
How did you redock it? My map is not docked and it's causing a mess.
This looks like that.
Yeah.
I think if you just kind of go in there, and you go to this middle part, it should dock. Mine has just messed up because it Because the things were already there. So you might have to do some moving stuff around. Okay, so I'm gonna close my soil descriptions. I don't need that. I just have soils Notre Dame up. I can see that one that I just did. And in fact, the problem there is it looks like there's a space at the beginning of it, actually. So if I double click on it and go in there, I'm now editing that layer, and I can just delete that space that's sort of leading there. Hit OK. And if you saw, when I corrected it, it automatically pulled it in from the other table. So you have an immediate feedback that you've done the right thing. So by the end of doing this process of editing them, you're going to end up with all of them matched. You may have had some of those weird little tiny like sliver polygons that were just right next to an existing one that had a null like soil code. This is a case to then go in and join those on as well. So you just take those and find the one that's right next to them and join them on. I can walk anyone through that when we're actually doing like we'll finish a little bit early and there'll be time to walk people through that process if we need to. I just don't have any of my sample stuff. So if I'm going to correct these other ones, this one also just has a little space at the beginning of them. And it pulls it right up as summons. Same with that one. But this last one here does not have a leading space on it. So if I jump to that one, you can see that this is a case where I just didn't capitalize the U at the end. So as soon as I go do that, it matches it over there also. So once I'm in that spot and I've fixed all of these things, I'm kind of ready to proceed. So this is sort of the pre-work that you're going to do before you get to the point of doing the actual assignment. And just as a reminder, because I just have been grading people's things, when you do the assignments, do them on the park that you're using, unless I distinctly say use the Notre Dame stuff or exactly what I do in the demo. You're repeating this process with your own stuff, not redoing the Notre Dame stuff. We've gotten to the point in the semester where I think I have hopefully said that enough times that I will start taking off points if it happens. Not that you can't then just resubmit and get those points back, but still, it's double the work, and you might not want to do that. Okay. So once we've gotten this, we have our soils sort of in place. We don't need the soils raster image anymore. You can just go ahead and remove it. And we're at a point where we have this join in place, but the join is actually temporary. It's in the map document. If I close this and reload it, it's still going to be joined. It's all in there. I could do this permanently in a database, but often what you want to do is just make a new copy of it that has all the joined information on there. But there's things that we don't want to have in. We don't need to have soil code in there twice. One is soil code and one is MUSIM. We don't need this unique identifier that came from the other table in there. So we have a couple of choices for how to do that, how to get rid of those. I'm going to do one of them on one version and I'm going to do one of each version of how to get rid of those. So if you wanted to, you can just turn off these values, and when you create a copy of it, it won't take the things that are not selected. So there's two ways to turn off whether something is visible. One, you can right click on it right here and go to hide field. The other thing you can do if they haven't broken this recently, because it kind of comes and goes in versions, is you can hold down Control and double click it, and it'll just disappear that thing. It hasn't deleted it, just turned it off. If you were to go into here, I think there should be show all fields. If you went into fields view, you could actually see which ones are visible and which ones aren't visible as well. So I'm going to do that for that one, and then I'll delete the other one in a different way afterwards. So with that in place, I have my temporary soils Notre Dame with the joined on soil descriptions. I'm going to right click on soils over here. And if I want to create a permanent copy of it, I'm going to go down to Data, Export Features. And this is going to let me make a new permanent copy. This data export blank is how you make a new copy of pretty much everything. So we've done this a little bit with raster data a few times. We're going to do it with vector data now. This just creates a totally new copy. The one thing to be careful of is remember that ArcGIS always does things on a selection first. So the default is going to be to only do that one feature I have selected, which is a real, why usually you wouldn't just want one feature in its new shapefile. Sometimes you do, but usually you don't. I could either unselect everything, or if I go into the export features, I can just turn off this use selected features. And it'll do all of it. So right now it's taking the shapefile that's in there, sending it to an output feature class. If you hover over it, you see it's actually sending it into the database. That is fine, but it'll be a little bit harder to find it afterwards. So sometimes it's good to just save this as a shapefile so that it's independent of those databases. And we do that again by walking over here. Instead of databases, go into folder. And I'm going to call it soils ND with description is yes. You can hit .shp, you don't have to, it'll default to that, I think, but it's probably a better habit to just get in there. Oh, sorry, I didn't actually put it in the folder. I'm in like the folders view instead of actually in the folders. Once I double click on the folder, it'll let me do save. So I'm not using my selected features. If you didn't have anything selected, that'll be grayed out already. I'm sending it to a permanent shapefile. If I wanted to, I could sort of mess with the fields in here as well, but I want to show you the other way to do it too. I'm gonna hit OK. Now I have a permanently saved soils Notre Dame with description. If I open the attribute table there, I still have that duplicated soil code MUSIM. If I right click on that, sorry, if I moved it over to the fields viewer. If I go over to the fields viewer, wherever it is, what did I add things? Might still be actively editing or something. So if I go over to edit, do save. Because I edited those things live, I needed to hit save before anything else happened. Which I didn't remember to do, but it's fine. It doesn't actually, it would have exported them properly, I hope. So soils with description. So my MUSIMs are all in there properly. Just gonna go up to table at the top here. I don't know why it's like grayed out down here, but I can hit it up there. Okay, couldn't tell you why, but that's where it is right now. Hit OK. So I've just deleted that soil code that's in there twice. You don't have to. I just don't need it. So it's probably better to just have less duplicated data in there than more. All right. So once we've done this, we have a couple of other things that we want to do, mostly around calculating new fields. So I talked about this a little in class. We're going to do the area of all of our soil codes. And then we're also going to just classify that area into small, medium, and large. So to do that first, we're going to come over here. If you're on the table thing up here, if for some reason it is in place, you can do it. We're going to go to we're going to create a new field over here. So I'm going to add field. I'm going to call first one area. I want this to be decimal places. So I'm going to change it over here to be double. And then if I wanted to add a second new field, I can just do that right here too. You see where at the bottom it says click to add a new field. I'm going to also do size class. It does not like spaces in field names. It still will not let you put a space in there. So I'm going to do size class. And then if I wanted to, I can do an alias. And this alias will be what it displays. So it's got one thing stored in the file and one thing that it displays whenever I use it. So if I wanted to, I could put size class with that space in it if I was being really precise about things. I could come up here and change this to be farmland if I wanted. And then maybe soil name. Just setting it up so that I have these to look prettier. There's no other real reason. If I don't have something defined, if I just leave area, it's just going to use area over there. So once that's all done, you can either hit save to save all of the stuff that you've just done, or you can just close it and it'll prompt you about whether you want to save it. A couple of people recently have told me that they accidentally hit the discard button on things like this. Discard will get rid of everything. You'll have to do it all over again.
Mine's add field is grayed out.
Probably need to save edits on the editor tab would be my guess. Okay, so I'm gonna save mine. Now I'm back in my table. You see I have, I made a mistake here. Size class was supposed to be text. If y'all did the same thing. I did, you would just right click on size class, delete it. And then go add another field. I'm gonna call it size class again. Basically what I did was I accidentally put it in as a long integer again when I meant it to be text. So not date, text. Save. Close. I had to do it that way. I had to delete it and redo it because it won't let me change the type once it's been made. If that happens and you want to keep the same name, just delete the one that you did that's wrong and then just redo it. It'll let you do that with no problem. Okay, so now what I want to do, pulling this out a little bit, is create that area field to be the area of each polygon. And then use that area to classify and calculate new values into size class here. I can right click on the headers of these and get to these things, calculate geometry, calculate field. They're also up here, but I'm in the habit of just coming here and right clicking on area so that I know it's the right one and going to calculate geometry. So it's going to ask you first about what you're doing. In this case, it's the input feature. We can actually create a new field. I didn't need to create area. I just wanted to show you how to do that. So we could create a new field if we wanted to. So I could create one that's perimeter also if I really wanted to, but there's really no reason to. So the field is named area, and then in the dropdown, we're going to do area. You see that there's a lot of these things that you can do. Some of them are pretty cool. Some of them are a little maybe less than intuitive. You'll see that area and perimeter both have their value, but then also geodesic. That's a way that you can calculate distances from latitude, longitude coordinates. So geodesic would let you kind of skip the step of projecting it into a meter-based system. So just keep that in mind if you ever need to do that. So you're going to choose area. And then do just remember that you want to have an area unit. You're welcome to choose whichever one of these you want for the assignment, but it'll be a little wonky if you don't choose square kilometers. Sometimes it'll default to square meters. That's fine. Does anybody know how many square meters there are in a square kilometer? 1 million. So your numbers are going to get really big if you use square meters. I personally like to just go ahead and cut off that million digit and use square kilometers. As long as I know what it means, I mean, you can convert back and forth between them by just dividing or multiplying by a million. So I would choose square kilometers. And then it will ask you about the coordinate system. You can choose any of these. I would say just point it at the one that it's actually working on, which is that UTM one. The map may be in that one. It may be in something else depending on what you brought in first. So I just, instead of going all the way through everything here where I was selecting my coordinate systems, I've just done the drop down there and then chosen one of the other layers. In this case, the layer that I'm working with, which I know that I put into the WGS 1984 one. Okay. And then when you're ready with that, just go ahead and hit OK. Calculate things behind the scenes. And you'll see that it comes up with the values really pretty quickly. If you had something selected, it would only do it on the selected, but in this case, it works pretty well. And if you want to, you can double click to go see why this is the case. So that's actually a pretty decent sized one, which is why it's over 1 square kilometer. That one's real dinky, which is why it's a little one. And you can start to sort them. So if you were to right click on the table of contents header, and go to sort descending, you'll see that in most parks, there's going to be one really big one. You probably remember that from when you were digitizing. Potato Creek, it's the lake. So, yeah.
Can you go over the field and property geometry attributes one more time?
Sure. Like just in here, if I go into calculate geometry.
Yep. Area.
Yep. So area is like the regular. If it's in meters, it's just calculating the area. Geodesic is using like the surface of the Earth, even if it's in latitude and longitude. So that's just saying that it's a way that you can do these calculations with latitude and longitude coordinates. It's not as accurate usually as just having it in a meter-based system, but it'll give you a number that isn't like square degrees, which doesn't make any sense. Whereas like other software will usually just give you that number as square degrees, and then you're like, what is a square degree? And it doesn't really work. Number of parts, vertices, holes, and curves is just something about the polygon. So if the polygon has holes inside of it, if it's got a lake cut out of the middle of it, if it's two parts, if it's got like Alaska and then like continental US, that would be two parts. All the islands of the Aleutians would be even more parts. So the US would be thousands of parts probably. The centroid is that central point. The centroid is a geometric, it's like the minimum latitude and the minimum longitude, minimum X and minimum Y, or mean X and mean Y of the points. The central point is the centroid that's automatically inside of it. It can't go outside of it. The minimum and maximum, I think, are fairly clear. There's different ones if you have a point, if you're doing this on points or you're doing it on lines. Also, the points are just going to give you like the coordinates basically. Lines will give you the length, and then maybe a central tendency one and a minimum maximum also. Okay, so once you have that done, you should be able to look at all of those and see sort of where you're at. The next thing we want to do is calculate this size class variable, where it's just going to be whether it's a small soil, a large soil, or a medium soil. I gave you values on here for Notre Dame. They hold up pretty well for the other ones as well. If you need to tweak some of the values, then you can. It's not a problem. When I originally wrote this, we did the calculation 3 different times, just so you would like be totally into like remember how to do it. We'd select, because the way you usually do a calculation in ArcGIS is you're going to select the things that are what you want, and then calculate just that selection to be things. So if I wanted to do the small features, which in this case I'm going to do as less than 0.05 square kilometers, I would go to select by attributes, find my area. And I'm going to do is less than, I don't need a unique value here. I'm going to do 0.05, hit apply. You'll see that it's selected them all up here. I had mine sorted, so it's only the stuff that's way down at the bottom, but things are selected. You can see it down here where it says half of them are selected effectively. And then I would right click here, go to calculate field, and in size class, just type in the word, in quotes, small, hit apply, and it's only going to calculate it on those selected ones. If you go all the way down, you'll see that they're down there. I think I've also mentioned that my long-suffering graduate student, Megan, redid all of my labs for ArcGIS Pro a couple of years ago. And Megan has no tolerance for repetitive, stupid tasks. So what she did in the demo notes is she wrote how to do the whole equation that'll do all 3 of them at once, instead of doing just the selecting these and then selecting the medium-sized ones and calculating and then selecting the large ones and calculating. It's useful to know both things, so I didn't change it. I was like, okay, we'll do it that way too. So I'm going to show you all how to do that longer equation as well, because it is basically just Python. So if you know Python, it should probably look a little bit okay. If you don't know Python, that's fine. You don't really need to, because it's all sort of written in the text also. So what Megan did, the way she had us do this, is instead of selecting individual pieces. So let me just point out as well. So the next thing we would do is instead of area is greater than, we just change this to greater than or equal to 0.05, add a clause. We want it to be the area is then also less than 1. These are just the classes. So this is how you do that like middle one. It's not immediately clear. Okay, but what Megan had us do instead was go into size class, right click on it, go to calculate field. And instead of doing everything else, we're going to turn off selected features if we had anything there. And she's going to have us do this expression type piece where we're doing expression type. We want it to be Python. This is Python 3. If the GIS world still used Python 2 until about a year ago, so this is fine. And what we're going to do is we're going to change quite a lot of things in here. So the size class is not going to be small. It's going to be small. We're going to type the word if. See, it automatically goes to blue because it's Python. And then click on area. And then just type less than 0.05. and else. Medium. If less than equal to, oh, I forgot to quote, to put the end of the parentheses on my medium there, which is why it's still in red. Red is just saying it's text. If is means, the blue means it's a statement that is like a reserved word. Less than or equal to area. I'm sorry. Over here, and if it's 0.05 gets repeated. So we're saying basically is area between 0.05 and 1. Didn't mean to put going the other way there. And then else again. Sorry, it's actually just else, not quotes. This is in the demo notes if it's my constant making of mistakes is bothering you. Large. If double clicking on area. It's greater than or equal to greater than or equal to 1. And then else quotes null. And then double close parenthesis. So if you're not familiar with Python, which is fine, what's basically happening is it's saying, hey, take size class, it's going to be small if this thing comes back as true, which is if the area is less than 0.05. Otherwise, it's going to get the value of medium if area is greater than 0.05 and also less than 1. So if that resolves to true. If that isn't the case, it's going to get large if area is greater than or equal to 1. And if none of those things are the case, it's going to get the value of null. Presumably that can't happen. Presumably there's no situation where it would end up with null because it's numbers. Unless it was null coming in, it wouldn't ever work out that way. So once you have that, I'm just going to highlight that and copy it so that if we don't run into mistakes. You can also try this verify button. That'll tell you if the expression is valid. So if you've made a mistake, if you've done something like this, where I just left something off, it's gonna throw an error on me. Once you have that, you can hit apply, and that'll just calculate them all at once. Doesn't look like it because I'm hiding stuff, but you see right there, large, medium, small, all the way down like that. So if you just followed along and you've never written Python code before, congratulations. You can now put that on your resume. I wouldn't recommend it because I don't even put Python developer on my resume because it's a much different thing than data science stuff. Okay. The other way, like I said before, is just to do the selections by hand. If you just hate typing in all that code, you don't need to. You can do it the old school way. All right, I'm gonna just clear my selection here just so I have everything in place. Now it would be pretty easy for me to go through and click on the wrong thing, change my symbology so that instead of a single, I'm seeing these things, I don't know, off of the soil size class. So small, medium, and large, and sure enough, you can see why they're that case. That's part of the assignment is to change those colors around. So you feel free to do that sort of thing. The demo notes now have a switch to the other part of stuff, which is the water sampling stations for all of Indiana. I'm a little torn because we're going to do the summary tables twice. I'm just going to go ahead and do it now. So I'm deviating from like the way that the demo notes are written, but it's all in the same spot. That way I just don't repeat the same thing over and over and over again. So if you're doing this, what we might want to do is find out what is the total area of urban land Tyler complex 0 to 1% slopes. Right now, we have it in there as multiple different areas, like because there's multiple different versions of that in there. It looks like there's 3, even at the top here. 3 different types, 3 different instances of the same soil type. So this is that situation where I was talking about before, where we can do a summary table off of these. If I right click here, there's a couple of things that we've looked at before. We looked at visualizing statistics and exploring statistics before. We can also do this summarize button. And this is that kind of pivot table, summary table thing that I was talking about before, where if I choose that, it's going to ask me what table I'm looking at, what I want to call the output table, what the case field is. In this case, this is the thing that you're summarizing by. So if I had a bunch of records for every state in the US, my case field would be state. If I wanted to find out what is the total population of Indiana versus the total population of New York versus the total population of Idaho. So my case field, and you can see I can do multiple ones. So if I had a really complicated table, I could have, you know, sort of like a group by in 2 different things. Just so I know, how many of y'all are data science minors? Should be a not insignificant number. Okay, it is an insignificant number. Got it. So I'm going to try not to just throw out a bunch of R terms and things because it makes sense if you've used it a lot, but if you haven't, it's not a big deal. And then it's asking me what statistics fields I want. In this case, it's area. And it's asking me what all I want to do. So do I want to get the total area, the mean area, the minimum, the maximum, range, standard deviation, first, last, median, variance, unique, and concatenate. Some of those things don't make any sense at all, probably. Some of them probably do. In this case, I probably want to do this total. And it might be nice to know the like the mean value. You could do minimum, maximum, range if you wanted to also, just so you had some measure of variability. And it's just letting me choose these things in here too. Once I do this, I could change this name if I wanted to, but this is fine. It's actually telling me something kind of useful about it. I could save it as a CSV or an Excel file, or probably not an Excel file, as a DBF or something if I wanted to also. I'm just going to leave it in the database, so you have it there. What it's going to do, pull up another new table for me down here in the standalone tables. If I load that up just by opening it, now I no longer have multiple versions of any given soil type that's in there. I only have one. And so I've gone from what previously in the soils here, I had 417 features. Looks like there's only 44 unique soil codes in there. So I just have those 44 unique soil codes. And you can see which ones have the biggest area. So the sum of the area, the total area. Oops. Smallest ones. So it gives you some useful information that UGVA one is actually pretty common. Not the most common soil type, but definitely the largest total area, and it probably has one of the higher mean areas also. It's a good way to get these summary statistics about a big sample of stuff. Okay. So the next part, what I'm going to do, I'm just going to close down these attribute tables because we don't really need them. We're going to switch to doing this water sampling station, USGS water sampling stations for the entirety of Indiana, which means that it doesn't really necessarily make sense to have this in at the same time as your park stuff. So just to demo, if we haven't done this very much before, I'm going to go up to Insert and I'm going to choose New Map. And that's just going to bring up a new tab up here. That's just a totally new map. I'm not overwriting anything. I'm not losing anything, but I just have a place to stick it so I'm not like trying to look at something that's zoomed in on Notre Dame campus and something that's on the state of Indiana as well. And then if I'm on map, I can go into my add data, into folders. And this is the one where I want water measurements and water sites. So I'm going to choose those two and hit OK. And you'll notice that precisely nothing happens because I've just brought in tables. I haven't brought anything spatial in, so I can't actually map it yet. But I can look at them just like I did before. If I right click on water measurements here, you'll notice that I have like an identifier for the station and the measurement here, what year it was taken, what the measurement parameter was, what the value that was given, and then the number of measurements. Some of these were like the mean of a couple different measurements that happened during that year. And then water sites, if I open that up, see I have that same station ID. I've got the location that it is, the county, what state it's in. I've got a latitude and longitude, and then I have a northing and easting as well. These are actually UTM. Often northern and easting will be like a state plane. We could use either one of them, really. Doesn't make a huge difference. So if we want to create an actual map out of this thing where we've gotten latitude and longitudes or UTM coordinates or anything else that we have here, we get to these pretty easily in a table by just right clicking on it over in the table of contents. And you'll see you have create points from table here. You have two choices, and these are choices that mean kind of two different things. One is creating it as a permanent thing, and the other is what's called an event layer. It's not actually like saving it anywhere. It's just live displaying it off of those two columns. So if you need to just see something really quick and make sure it is in the right place, and then go edit it somewhere else, that event layer is fine because you're not going to bloat your database with a bunch of things that you're just trying on stuff. If you're doing it in, if you know that we want it to be permanent at some point, XY table to point is what you want. The demo, I'm just looking at the demo notes. I have it up on the other monitor, and they didn't. This is a new feature to be able to do it either way. It used to be it always gave you an event layer, and then it always gave you a permanent thing. And I'm sure somebody just complained to them about bring back the old version. So we're going to do XY table to point to just skip out that event layer. So our input table is water sites. Our output feature class right now it's sending it into the database. We want this thing to be accessible. So I'm going to go back into folders, lab 6 tables, and I'm going to type in water underscore sites underscore spatial. And this is the point that I was complaining about. Please don't put a C in spatial. .shp. My mother was a journalism professor, so I had grammar and spelling drilled into me from a very young age. And it was always a big criticism point, you spelled that wrong, you used a comma in the wrong place. But I'm also dyslexic, so I cannot physically spell things right a good percentage of the time. So it was always sort of this fun, you will do this right, but I physically can't. If you see me do something really silly, like put the shoe on the wrong foot, then that's probably why. Okay, so we have that in. We have a new shapefile that we're sending it out to. It has an X and Y field here. It's guessing that we want to do this in the geographic coordinate system of 1984 because our fields are called long and lat. And that would actually be fine if we were doing things in latitude and longitude. I've already told you that there's UTM coordinates in here, so why don't we just start with the UTM coordinates instead of dealing with the latitude and longitudes? So we're going to do those by going into X. Your X field is going to be easting. Your Y field is going to be northing. And then we do need to change this because we are not working in a geographic coordinate system. We do not have the ability to change it into something we want because if the default for the map is this Web Mercator Google Maps coordinate system. So we do want to go into select coordinate system in this case and go through our little chain here of projected, UTM, WGS 1984, Northern Hemisphere, Zone 16 North, hit OK. And then hit OK. So once you have that all filled in, you should be good to go. Input table, water sites, easting, northing, we're going to send it through that way. And sure enough, there they are. Those are all of the UTM coordinates projected onto UTM coordinates of all of those water sampling stations for the state of Indiana. And if you zoom in on it, you can sort of see oh, imagine that. They sort of follow rivers sometimes. There's quite a few of them that are within Lake Michigan. But then there's also ones that are just sort of random places throughout. So this is why I don't have you do it for the parks, is that there's just not a lot of them in the parks, and rather than use fake data, I thought it would be fun to use real data. But if you remember, we also have these water measurements. Tab's still up over here, where we have the actual measurements, but the same station has probably got, you know, it's got hundreds of measurements probably throughout the entire database here. And we want to then create this sort of relate between them, this one-to-many relationship. So we can either look up all the measurements that happened at a particular site, or we can look up where particular measurements happened on the map. And that's where we create this sort of link between them that we call a relate. In this case, it doesn't actually matter which one you start with because it goes back and forth between the two. But I'm just going to start with water site spatial here. And I'm going to go to joins and relates. And instead of add join, I'm going to choose add relate down here. And it gives me a nice little pop-up that says that this is a standalone table based on a common attribute. It does not append data onto the layer or the standalone table. Water site spatial, water measurements. Again, it's only doing this correctly because there's only 2 layers in there. The thing we're looking for to link them is station. It will probably default there. Relate name, you could call it something different. You could call it the names of the tables. We're only going to do one relate, so you can just leave it as relate 1. And then you do have the ability to kind of which direction you're going. I've never had to change it from 1 to many, but you could, depending on how the structure of the things is. Okay, so I'm gonna hit OK. And you should presumably notice that precisely nothing has happened. Because it doesn't do anything other than make the link between those tables. However, what that does mean is now if I go into water sites spatial, I'm just going to close water sites here because it's not, I'm just going to remove water sites so I don't get confused about it. I'm going to open water site spatial attribute table here. If I choose White River at Perkins right here, assuming that's what that is, all right, Perkinsville. If I look up in here, I have some things I can do to kind of get back and forth between the different tables. So if I select whatever I want to, and then I come up onto the table thing up here, it's probably over in here also. Yeah, it's related data, water measurements. It may be at the top of your screen as well if you've got a bigger monitor. I can go in through here, go to related data, and it's going to pull up all of the samples that happened at that station. So it's just gone back and forth between the two and found the 25 measurements that happened at White River at Perkinsville. No matter what year it is, no matter what measurement it is, all the way across that way. So it's a pretty cool way to be able to link these 2 things together. And the exact same thing is true no matter which table I kind of start with. See, there's like almost 22,000 records in this water measurements. And if I wanted to say find all of the times that dissolved oxygen was of a certain level, we'll say above 5. I could come in here, I'm gonna clear my selection. I'm on selected view, so I'm gonna go back over here. And then I'm gonna go to select by attributes. In this case, I'm in my water measurements. I'm gonna choose the case where my parameter is equal to dissolved oxygen. And also my value is greater than or equal to, let's just say 5. I don't remember what I said before. Gonna hit OK or apply. You'll notice down here, it's now selected 3,186 of those 21,000 records. All the cases where there is a dissolved oxygen and it's above a certain level. Some of these are much lower. And again, I can go, I'm just gonna close my select by attributes because it's ready. Related data. Oh, did not let me go back and forth between. Water site spatial, it's in related data. Now it's showing me on a map where all those sites are. So you see, for some reason, the at some point throughout history, almost every station along the St. Joseph River had a dissolved oxygen greater than 0.5. If anyone's done aquatic stuff, marine science stuff, that's absolutely no surprise for a moving body of water that it's going to be a little bit more oxygenated. But it is the case that that's happened. Every once in a while, I get to use my marine science degree, and that's one of those moments when I get to. Okay, so related tables, we're just doing this back and forth between them. So we're gonna select something in one, we're gonna go right back to the other one. And that's kind of how we do it with it. If you remember as well, though, I talked about summarizing fields as a way to take a one-to-many relationship and create a one-to-one relationship out of it. And that's exactly what we want to do here. So if I wanted to, I could create some sort of summary table off of my water measurements and have that be the thing that joins on to my water sites. The way to do this, though, is first we're going to just pick something that we want to do. I'm going to pull water measurements out again, just so I have a little bit bigger view of it. You remember, so we talked about before, what we have in here is we have this ID, the station, the year, the parameter, and then the value. So I just want to select something that is something I could summarize kind of first. So I'm going to clear my selection. And I'm going to say I want to select all of the measurements for water hardness that happened in some particular year after 1990 or something like that. So I would go to select by attributes. It kept my last one in here. I can just delete these if I want to. Add a clause. I'm going to do parameter is equal to hardness. And also year is equal to, I guess those are not in his numbers. I might be able to do greater than, I might not be able to. Yeah, I guess I can. Year is greater than 1989. It selected 100 records in there. That's not a huge number, so we probably won't have a huge number of sites that this measurement has happened on. I could just do this and just do the hardness measurements as well. That'll give me 4,000 or so. So once I have that selected, I've just selected my hardness measurements. If I come to station, right click on it, and I go to summarize. I'm using those selected records. I'm going to come in and I want to do the value here. I don't want the sum. I probably want the mean. I may also want the minimum and maximum. Oops, that's the wrong one. Because what this is doing is it's giving me, for that value, the average value of all the samples that happened at that station for water hardness, the minimum value and the maximum value. Case field is station. When I hit OK, I get a new table, water measurement statistics. I open that up. It's hidden back here. For each station, I have the number of measurements that happened, the mean, the minimum, maximum value. It looks like quite a lot of them just had one measurement for water hardness, which is why they're all the same. But if you get to ones that have two, you get sort of the mean, the minimum, maximum. There's probably some that have more than that. Frequency sort of descending. Yeah, so there's some that had as many as 11 in that time period. So now that I have this one-to-one relationship, so each station has just one measurement of summary statistics. Now I could go to water site spatial, right click, joins and relates, add join. Going to join water site spatial based off of station, not to water measurements, but to water measurement statistics based off of station. I can keep all input records. I could also remove, like just only keep the ones that have a value if I unchecked that. In this case, I probably want to do that because there's just not a huge number of them. Hit OK. It hasn't deleted anything out of water site spatial, but they're just not being displayed anymore. So those are the stations in water site spatial. Clearing my selection that have a hardness measurement. And it's been appended onto the end here. for them. And it wouldn't be very difficult for me to go through, click on my symbology, go back up, change that single symbol to be, we'll say graduated colors. The longitude, because that's just going to show me one thing, but I might want the mean value. Now it's sort of colored based off of whether it's a higher or lower water hardness measurement that's happened at those spots. So you can see how I can take that one-to-many relationship and coerce it into a one-to-one relationship without too much difficulty, just by sort of summarizing things.